So now that you know about proportions and measurements and similar figures, we can move on to scale drawings. Let's go over 3 vocabulary terms for this lesson. First, we have scale drawing. A scale drawing is a 2-dimensional drawing that is similar to the object that it represents. Next, we have scale model. A scale model is a 3-dimensional model that is similar to the object that it represents. Now, notice the word similar is in both definitions for both these terms. What that basically means is, for a scale drawing, you will have a drawing, maybe a blueprint, maybe a map, with some drawn representation of a real-life object. And the measurements in the drawing are similar, in other words, proportional to the measurements of the actual object. And the same goes for scale models. The dimensions of the models are proportional to the dimensions of its similar figure, the real-life object. And then we have scale. The word scale means the ratio of the dimensions of a drawing or a model to the dimensions of the represented objects. And now I want to show you, before we move into our 3 examples, I want to show you the proper way to write scale. There are 2 ways that you'll see scale written as we're working through this lesson over the next couple of days. The first way is here with a colon. And the first number that you'll see in this ratio would be the measure of the scale, whether it be the scale drawing or a scale model. This measurement would be for the scale, and its ratio is to the actual measure, so the measurement of the real-life object, which means that the scale measure, your first number, is always going to be smaller than your second. Now, the second way, and the way that we'll use most often in this lesson, is the fraction representation of the ratio. And if you remember from last week, the figure, or the number that comes first, the information that comes first in this colon form of the ratio gets represented into the numerator of our fraction, and then the measurement that comes next goes in the denominator. So if you were to write this out, it would be scale measure over the actual measure. Now we can get started. This says that a map has a scale of 1 centimeter equaling 8 kilometers. So I just rewrote that scale in the first form that we saw on the previous board. We have 1 centimeter to 8 kilometers. What is the actual distance between 2 places that measure 5 centimeters apart on the map? Well, since we're talking about ratios, we are going to take our scale and write it into a fraction, which is 1 to 8. And we have to remember our units, 1 centimeter to 8 kilometers. And because we have to compare this to another measurement, it means we have a proportion. So we're going to make our scale equal to a fraction. So how do we know what goes where in this fraction? Well, since we have centimeters up here in our numerator, it means that centimeters must be in the numerator of our second ratio. So kilometers is here in the denominator, kilometers belongs right there. So let's take out the other information that we have. We're looking at 2 places that are 5 centimeters apart. So the 5 comes up here, and we want to know what the actual measurement. So in other words, we have to solve for the kilometers. And when we learned how to solve proportions, I taught you 3 different ways. One way was to find an equivalent ratio. The second way was to use algebra, and the third was to use cross products. Now, the algebraic method would not help us here because that only works or it's only simpler to use when the variable is in the numerator. So we have 2 options. We can either make equivalent fractions, or we can get a cross product. Either way, we'll get the same answer. So let's do cross products here. 1 times x is 1x. We cross simplify here. 8 times 5 is 40. So on this map, with the scale of 1 centimeter to 8 kilometers. Two locations that are 5 centimeters apart on the map are actually 40 kilometers away from each other in real life. Now our second example here is a little bit more complicated and more involved, and as you can see we have some steps interspersed with our work, and I thought this would be the easier way to go. Let's start by reading the problem. In a scale drawing, a table is 3 inches long. Its actual length is 8 feet. Find the scale of the drawing. So what we're doing here is we're taking the scale and the actual measurements, and from there we have to determine what the scale is, which means we have to solve this in such a way that gives us a number 1 in the numerator. So let's take a look at our first step. Our first step here is to write the ratio in fraction form. Notice I started off with our formula of sorts for writing scale, which is the scale measurement over the actual. And I make that equal to what I do is I make that a fraction with the information that we're given. We're told that the scale drawing is 3 inches long and the actual table is 8 feet long. Let's move to step 2. Convert the larger unit to the smaller. What that means is, this is almost like when we're using a unit rate, we want to, no, I take that back. What that means is, since we are looking to have our numerator be 1, and we want to know what the exact scale is, we have to work with common units. And not just common in that the numerators are the same and the denominators have the same. Common in that every single number uses the same unit. And we have to convert larger to smaller. When we're working with inches and feet, inches is the smaller unit, which means we have to take our 8 feet and convert that into the number of inches that it is. So I set up an equal sign and a fraction bar. Since our goal is to work with inches, our 3 inches just gets moved over, it's untouched. But here we converted 8 feet to 96 inches. Because you remember that there are 12 inches in 1 foot. So 8 times 12 would give you 96 inches. Now this is not the end, this is just step 2. We are still working toward finding the scale that's being used. Step 3 is to simplify the fraction. So here, from our previous board, we ended off with 3 inches to 96 inches. 3 is the greatest common factor, and remember we want a 1 in the numerator, that's our goal. This simplifies then to 1 inch over 32 inches. And then our final step is to simply rewrite the ratio using a colon. So we left off with 1 inch to 32 inches, and so the proper way to write that, given our directions, is 1:32. So the scale is 1 to 32. Here's our final example for the day. A blueprint scale of a house is 1 to 42. Find the actual length of the wall that is 3 inches long on the blueprint. So just to further explain what we're looking for. A blueprint, if you don't know, is a drawing of the plan of a house. And so what they're saying is the scale that's being used is 1 to 42. And we have to use this ratio to help figure out how big the actual wall is that has to be built, or that has been built of the house. If on the blueprint it is 3 inches long in the drawing. So again, I start with our formula that the proper way to find scale is to take the scale measurement and put that over the actual measurement. For this problem in particular, we start with the scale that we're given, which is 1 to 42. The 3 inches that they give us coincides with the 1 because they're both in the numerator. We have the scale measurement, and we're looking for the actual. I used my cross products. Again, algebra wouldn't work since the variable is in the denominator, But if you wanted, you could use equivalent ratios. Again, I did cross products. 1x equals 42 times 3. And we get an answer that x equals 126 inches. So, using this scale, a drawing of a wall that is 3 inches long in actuality is 126 inches, which I divided by 12 and converted to 10.5 feet.